Good evening. Today I will be going over my approach to solving Exam 3 Question 2, which covers resistance capacitor circuits. To begin this problem, you must first have a thorough understanding of capacitor behavior, as well as how to write loop and node rules. The question is as follows. Consider this circuit with a switch that has been in position A for a long time. The circuit has two batteries with EMF of V at position A and V/3 at position B. The circuit also contains a capacitor of capacitance C and two resistors with their resistances given in the figure. At t equals 0, the switch is moved to position B. Part 2.1 asks us to find the initial charge on the positive plate of the capacitor just before the switch is fully charged. Because we are familiar with the behavior of capacitors and resistors in a loop, we know that after a long period of time t, there will no longer be any current flowing through the resistor, as it will all have been used to charge the capacitor. Thus, we can create the loop rule for this scenario as follows. The net voltage is 0, which is equal to the voltage of the EMF, V, minus Q over C, minus the voltage across the resistor, which we know cancels out to be 0. Thus, V is equal to Q over C. This can be rearranged to solve for Q, which we find to be CV, our initial answer. Note that it is important that you include a positive sign on your answer, as the question is asking about the positive capacitor plate. In part 2.2, we are asked to find the maximum current that passes through the resistor with resistance R once the switch is moved to position B. Remember that when the switch is moved to position B, there will be a new loop that we will be analyzing, which includes the EMF with the voltage of V/3 rather than the EMF with the voltage of V. Note that the maximum current which passes through the resistor Note that the maximum current which passes through the resistor will occur initially. Also note that the capacitor will be used as the EMF for this part of the problem. This is because it has a voltage of V from part A, which is greater than the voltage of V/3 from the new power source that is unique to this loop. Thus, we can set up the net voltage loop as follows. 0 equals V minus I max multiplied by R minus I max multiplied by 2R minus V/3. We can manipulate the equation to solve for I max, which we find to be 2V over 9R. Note that we are only able to set up the equation where the current I is the same throughout the loop, since the circuit elements are in a series. This behavior would be very different if the elements were in parallel with each other. In the last section of the problem, we are asked to imagine that both batteries are connected to the system using a wire which short circuits the top wire to both sections A and B. The currents passing through the left and right batteries are IA and IB, respectively, and the charge on the capacitor is Q. Write down the loop and node rules for the circuit. The first step in tackling this problem is to divide the circuit into loops that we can analyze separately. Loop 1 is shown in yellow, loop 2 is shown in blue, and loop 3 shows up in green. Next, we need to set up the three separate loops. For loop 1, the net voltage is 0, which is equivalent to V minus the resistance R multiplied by the sum of the currents traveling through the loop, IA plus IB, minus Q over C from the capacitor. In loop 2, the net voltage 0 is equivalent to V/3 minus 2R multiplied by IB minus R multiplied by IA plus IB minus Q over C. Lastly, for loop 3, 0 is equal to V minus 2R times IB minus V/3. The node rule equation for this circuit is IN is equal to IA plus IB. Before you begin your exam, you might consider trying this problem once again, but add a twist. Consider adding another capacitor at site A. What, if any, changes would be made to the node and loop rule equations? Best of luck on your exam!